Good morning, people. I think the mic might be decent because it's not sticking in a tube today. Okay, so good morning. Yes. So, of course, neutron decay cosmology, because me. And so in talking about neutron decay cosmology and Shirley's surface, actually, let's call that up because I can, which is the shape that I think works to describe the entire process of the universe quite nicely. Yeah, oh no, that was it before I was messing. So let's load. Boom. Okay, now let's get rid of some stuff. Let's get rid of the red ball and white ball. And this. Oh no, that's what we keep. Okay, right. This is Shirley's surface. And I use it to describe the universe in conjunction with the cardioid because this form does not really, this is symmetrical. The universe is not symmetrical, but this displays the flow diagram where let's say this top is gravity. All of this part is gravity coming in from this. The bottom part is neutron decay. The entire bottom half is one neutron decaying into maximal. And then the entire top half is maximal contracting into minimal volume. And that's why we put the curve on top. So that half is neutron decay and a little bit of reestablishment, I guess, probably into monatomic hydrogen. If we did the math, the curve of the cardioid, okay, if the curve at this tiniest part that's almost flat, but not quite, because as soon as you go out from axis, there would be a slight dip. So, okay, so that would be lambda. You exponentiate lambda, right, until gravity gets greater and greater. And I'm going to take out this so we can look at that. There we go, right? The cardioid shape is all the possible tangent angles until catastrophic event horizon, where you're actually 90 degrees, you're radial, you're not tangential anymore, you're radial. What the heck? Look what happened. Okay, and this instead describes Shirley's surface is just the closure over time of this process where you fall in the event horizon. You're on the top, you're on the outside. When you fall through the event horizon, suddenly you're on the inside. You're antimatter. And then you do a circle of as antimatter. Then a circle is matter. But the truth is that this is a single-sided surface, which I'm about to prove. And since that is the case, you are always both on the inside and the outside because it's a single-sided surface. You can't be on one side or the other really on a single-sided surface. So topographically, to describe Shirley's surface, I was challenged by this topologist that I was doing some emailing with about, creating one of these diagram things that they make where you take a torus would be like this, and there would be arrows going this way, right? Because you'd close this and this would match. And then there'd be arrows parallel this way because these two ends would match, only it would be a tube, so it would make a torus. But I'm making the Shirley surface. So one thing about the postulate of neutron decay cosmology is that there's a neutron in deep space. The neutron decays, expanding in volume, this neutron decay. This process is an expansion of 10 to the 45 This is from minimal volume, maximal density, to, in terms of matter, maximum volume, minimal density. Okay, it's the weakest, the biggest hydrogen ever gets to be is out there. And then gravity brings it back to here, which is also here. So this would be the paper thing of Shirley surface, whatever they call these things. Right? The flow is ADS, ds, closed over time, so that these ends match. So this would look like a torus. If you put 4 of these together, it looks like a torus, right? Because this would be also gravity. And notice how these flows match up. 1/2 gravity, 1/2 neutron decay. And if I had tape, clear tape, I could do this, but I don't right now, so I can't be bothered finding it. Okay, there. And then neutron decay on the other side. The red dots match up. And instead, so this looks like a torus, like if these were all puffed out like this, right? So they're tubes, and then this tube would join on this tube. Or this is like a pasta shape. Right? And this like that. But if that was the case, if things were a torus, then matter would be on the matter side, always. And antimatter would be on the antimatter side, always. Because there would be no perforation. And, you know, if the surface is a true surface, then it's not flippable. But with Shirley's surface, it is flippable you just have to go through, you vectorize it. Once you renormalize, once you've gone past infinity and you start back in, it's like you flipped over. And now this would actually be like this, and then it would go on the inside, but I didn't mark it, around once, and then again, single-sided surface. So, monsieur, here is the diagram. Yes, there's a catastrophe at this point. And maybe that's problematic, and maybe the universe just has a catastrophe. There's one point in the universe that you can't tell where you are because you're all places at the same time. And that's this node. The Janus point and that other guy's theory, it's all the same thing. It's the Aleph in Georges Louis Borges' stories. Everything flows to one point, and then everything bursts out of their individual points to flow together again. The center, the singularity that everything flows towards, is the periphery, the scattered points. Aggregated singularity on one side, scattered, distributed, the entire surface of the universe on the other. And it is exactly this contrast between vacuum on one side and maximal density on the other that by having a perforation you create a flow. So this is neutron decay cosmology, and this is the shape. You need to make neutron decay cosmology doing that topology thing where you take flat pieces and draw the flow on them to demonstrate the structure of your shape. And ça c'est là, le voilà. Peace, have a great day, sunny here.